Let's look at what slope means in word problems. So in the real world, when there's a slope, it's the rate at which something changes, or a rate of change. So this graph here on the dependent axis, or the y-axis, maps the distance that somebody has run. And then on the independent, or the x-axis, it maps the time that they have been running in seconds. So the first question is, find the slope of each line and interpret its meaning as a rate of change. So let's have a look first at Adam's line here. This is his running line. And you just pick 2 points. In this case, all 3 lines go through 0, 0. So we'll use that in each case because that's just easy to use. And then we'll find, here's a point here at 5:15. So for rise, to get from here to here, you go up. So we're going to go up 15, 5, 10, 15, and then across, what is it? 5. Okay? So our rise over run in this case will be positive 15 over positive 5, which reduces to 3. Let's look at Ben's line. So Ben goes through 0, 0. Also goes through, I mean, we could pick any point along here, but you want to pick one that sort of falls on a whole number in both cases. So here we have 10 in the independent and 20 in the dependent. So if we start at 0, we're going to go up 20. And we're going to go to the right 10. So you'll end up with a rise of 20 and a run of 10, and 20 divided by 10 is just 2. Let's look at Sierra. So we'll use 0, 0. We can use this point here, which is 15, 10. So we go up 10, and we go across 15. So you'll get 10 over 15 here. And because this is a word problem, we don't need to stick to fractions. It's actually more useful to use decimals. So this is approximately 0.67. And if we interpret what these slopes mean, you'll notice that all of our rise over run is a distance over a time. And distance over time is just speed. So as our interpretation, we can say, therefore, Adam's running speed is 3, and once again, rise over run was distance over time. So our distance is meters over our time was seconds, so the speed is 3 meters per second. And then Ben runs 2 meters per second, and Sierra runs 0.67 meters per second. Let's look at a different example. So here we have a graph, and this is if you were to host a party and you needed a big place to host it. These are 3 different venues or places you can host. This is the cost of the venue in dollars, and this is the number of people coming along here, because often a venue will charge based on how many people you're bringing in and how much resources they need to provide for those people. So it says find the slope and initial value for each line and interpret their meanings. So slope we've learned about. Initial value just means where does the line cross this y-axis or dependent axis. So let's look first at venue A. So venue A, here, let's look at the slope. So the slope, we can use 0, 0 here, and we can use 10, 25 here. So we're going to go up 25 and to the right 10. So our rise over run will be 25 over 10 which is just 2.5. And our initial value, we're going to use the letter B for, starts at 0 here on the dependent axis, sorry. So what this means in terms of interpreting their meanings is that it costs 2.5 is $2.50. Per person. So once again, the cost is here, so that's like our rise, over or per the run, which is the number of people. And because there's no initial value, that means there's no flat rate. So there's no rate that you have to pay at the very beginning or initially, you just pay per person. Let's look at venue B. So our slope is, let's see, venue B here. So we have this point here at 0.50, and then we have this point here at 20.75. So we can go up from 50 to 75 is 25, and from 0 over to 20 is 20. So our rise over run will be 25 over 20. Which, because this is a word problem, we'll leave it as a decimal, and it's 125. And the initial value here is 50. So we can say B equals 50. And what this means in terms of interpretation is it costs $1.25 per person. And the initial value is 50, so there's a $50 flat rate. Now, if we look at venue C, you'll notice that it is not sloped at all, it's just flat. And when you have a horizontal line like that, the slope is just 0. And that's the way you can think about it, is if you're walking along and it's not sloping up or down, then it's not sloping at all, so it's 0. So our M value is just 0. And our initial value is 150. So our interpretation of this, there's no per person, there's only a $150 flat rate. So which venue is cheapest for a party of 50 people? So all you do here is you go to 50 on the graph and you follow up. So this line, the lowest or the cheapest, is venue B. Then we would go to venue A and then venue C. So therefore, by the graph, venue B is cheapest for 50 people. And if you check the graph here, it's going to be roughly $110. And if we had picked a different time or a different number of people, say 10 people, A would be the cheapest. If we had picked 80 people, you would see that eventually venue C is the lowest, so that becomes the cheapest. So it really depends on how many people you are having at this party.